There are 60 students at a college, 20 students study both French and Spanish, so we're going to put them in the middle of the Venn diagram. 13 students study French but not Spanish, so they're going to go here. And 43 students study Spanish. Now we can't put 43 here because that 43 includes the 20 that study French as well. So we're going to be left with 23, and that means that the whole Spanish circle adds up to 43. That makes 56 students. And we know that there are 60 altogether, so that means there are 4 students who do not study French or Spanish. One of the students at the college is to be selected at random. Write down the probability that they study neither French nor Spanish, so that's these 4 students here, and it's 4 out of, we're only picking from all of the students, so it's just out of 60. That would simplify to 1 over 15. If you did that, great, that's also acceptable, but you didn't need to simplify it as it didn't ask you to. Jean records the maximum daily temperature each day for 10 days. She also records the number of children going to a paddling pool for each of these days. She draws this scatter graph for her information. So we have the maximum daily temperature on the x-axis, and we have the number of children in the paddling pool on the y-axis. First question we're asked is, Jean's information for one of these days is an outlier on the scatter graph. Give a possible reason for this. Now, an outlier is a point or a value that does not fit the trend of a data, and we can see that this point over here is the outlier. We've got the data mostly following this pattern, and this point here does not follow that. Give a possible reason for this. Well, on this day, we can see that the temperature was high, but not very many students went to the paddling pool. It might be that this is a school day, so I'm going to give that as my reason. It may have been a school day. You could also have, perhaps it was raining on that day. It could still be hot but raining, or give any reason why the temperature might have been warm, but there wouldn't have been very many students at school. At the paddling pool. What type of correlation does this show? Correlation is either positive or negative. Here we can see that the values are going up. There's a positive correlation. The hotter it is, the more children at the paddling pool. That's a positive correlation. If it was coming down, then it would be a negative correlation. Then it says on the 11th day, the maximum daily temperature was 19 degrees. Ruler. There we go. Write down an estimate for the number of children going to the paddling pool on the 11th day. Now, 19 degrees is here, so we might make a guess that the point needs to be somewhere around here. However, what you should always do is draw your line of best fit. Something like that. So we're going through the middle of as many points as we can. You should try and have the same number of points above as you do below, and I've almost managed that. So that if you took the data away, you'd still be left with the line, and that would show you roughly where the data sat previously. We're then going to go to 19 degrees. That's what we're asked in the question. We're going to read up, hit the graph, and go across, and I get 19 students for that. Now that's okay to take data from that range because we have data from that range that we can use to inform our decision. For the next section, it says it would not be sensible to use a scatter graph to predict the number of children going to the paddling pool on a day when the maximum daily temperature was 13. Why? Now, 13 is here, all the way down here on the graph. We don't have any data for when the temperature is that low. It's outside the range of data that we have. So outside the range of data that we have, or we don't have any data for when the temperature is that low. Simultaneous equations is when we need to solve 2 equations at the same time. So you're looking for an x and a y value that makes both of these equations work. So 4 times something, add on y makes 10, and x take away 5 lots of that y value also has to make 13. So it needs to make both of these equations true. The way to solve this is to make these terms the same. So we have y and we have 5y. You can make both of these terms the same, 4x and 4x, but I see it go wrong more often in that case. I would always encourage you to make the things in the middle the same. So to do that, we're going to times everything on the top by 5, and we're going to keep the bottom one the same, so that we'll have 5y and 5y. So timesing everything on the top equation by 5, I've got 20x, add 5y is 50. And the bottom equation staying exactly the same, x minus 5y is 13. We then need to remember Same signs subtract, add if different. Same signs subtract, add if different. And you're looking at the signs of the things you made the same. So we've made these the same, so we're looking at these signs. One's a positive and one's a negative, so we're going to add if they're different. Turn it into a big sum and add. Had we have made these both 4x at the beginning, then they would have both been positive 4x, so we would have done same signs subtract, but we did the middle thing, so we're going to add. 20x add another x is 21x. 5y minus 5y, or 5y add minus 5y, is nothing. That's the whole reason we've done it, is to cancel out a term so that we've only got one value, x or y. 50 add 13 is 63. Now 21 multiplied by x is 63. Divide both sides by 21, and that goes in 3 times, so x is 3. Once you know what one of the values is, we're going to go back to the original equations and substitute that in. I'm going to just take the top equation. It wouldn't matter which one you use, just use the one you like the look of better, whichever one looks like it will be easier to work out. So we now know that with 4x add y equaling 10, we know that x is 3. So 4 times 3 is 12, add y equals 10. Because we know now that this is 3, we worked that out down here. 4 times 3 is 12. I'm going to take 12 away from both sides. So y is minus 2. 12 take away 2 would make 10. That's my y value, and we're done. You can substitute those values back into here, and they make 13, so we know we're correct. Gina finds out the price of a CD box set in 3 different countries, and we have the price in different countries and in different currencies. Gina wants to pay the cheapest price for the box set. From which country should Gina buy the box set? Now, for this question, we need to get them all in the same currency. So you might get them all in pounds, you might get them all in dollars, you might get them all in euros, okay? We've got that choice. However, I've just had a look and thought, well, we've got pounds to dollars, we've got euros to pounds, and we've also already got the UK one in pounds. So I think this question will be easiest if we make them all in pounds. So I'm going to go UK in pounds, which we already know is £98. I just find it easiest to lay out my work like this. And also because then the examiner finds it really easy to see where your answer is. So we've got UK, USA, Germany. I already know that the UK is £98. In the USA, I've currently got it in dollars, and I want it in pounds. Now I know to get from dollars to pounds, I'm going to divide by 1.43. If I was going this way, I would times by 1.43. So if I'm going this way, I divide by 1.43. So dollars to pounds is dividing by 1.43. So take £134.99 and divide it by 1.43 to get it into pounds. So that one is £94. Let's write it all out just for now, since we're it's not a final answer yet. And so we'd say £94.40 if we're rounding it. And just write down what sum you've done. So £134.99 divided by 1.43. And that's that. And then for Germany, we're going euros to pounds. And to get from euros to pounds, we're timesing by 0.73. If we were going from pounds to euros, we would divide by 0.73. So I'm going to take £139.99 and times it by 0.73. So again, using my calculator paper. And that is £102 and 1927. So £102.19. So we can see that the USA is the cheapest country in relative if we got them all in pounds. So we need to answer the question, from which country should Gina buy the box set? She should buy it from the USA. That's definitely the cheapest of the 3. Gina lives in the UK. Why might your answer to A not be the best country for Gina to buy the box set from? And the answer to that one would be postage costs. It's all very well and good saying that it's cheaper in the USA, but if they're going to charge you more than £3.60 to ship it, then it's actually better off getting it in the UK. So standard form, write 3.6 times 10 to the power of 4 as an ordinary number. Now this just means we're going to times it by 10, times it by 10, times it by 10, times it by 10, 4 times. So you can either think of that as doing it individually. 3.6 times 10 is 36, then 360, 3,600, and then 36,000, and so on. Or you can think 3.6 by times by 10, times by 10, times by 10, times by 10, and fill in the zeros. So 36,000. Don't fall into the trap of just adding on the number of zeros. Okay, you need to think it would take one jump to get round the 6. So that would be 36, and then it would be timesing by 10 3 more times. Work out the value of 2.8 times 10 to the power minus 2 divided by 4.7 times 10 to the power minus 5, sorry. Now we have got a calculator, so I'm just going to go ahead and type this in. So exactly as it is there, to the power of minus 2. If you want to do a power that isn't 2 or 3, you need to use this button here, and it allows you to write any power that you like. And we're dividing that by 4.7 times 10 to the power of 5. And that gives us our answer in standard form. However, they want it correct to... Oh, where can you see it? There. They want it correct to 3 significant figures. So we're going to do 5.96, because the 7 rounds up. 5.96 times 10 to the power minus 8. The bottom of the ladder is on a horizontal ground. The top of the ladder is leaning against a vertical wall. So we've got the wall here and the ground here. The bottom of the ladder is d meters above from the wall, and the top of the ladder is h meters above the ground. The angle between the ladder and the ground is x degrees. Some safety instructions say that it is safe to climb the ladder when the height is 4 times the depth from the wall, or distance from the wall. Work out the value of x when h is 4d. So I'm going to change the h here to be 4d. I've got 4d and I've got d. Now the most important thing here to realise is that it doesn't actually matter what d is. It could be 1 and 4. It could be 2 and 8. It could be 3 and 12. But the ratio, the proportion doesn't change, and therefore this angle wouldn't change. So I'm just going to use 1 and 4. I'm going to draw a triangle where we say this is 1 and this is 4, and I'm being asked to find the value of x. So this is actually a SOHCAHTOA question. For SOHCAHTOA, we label our sides. This is the hypotenuse. This side is opposite because it's opposite the angle that we're interested in, and this side is next to the angle that we're interested in, so that's the adjacent. We're after an angle, so in this case we need the O and the A to be in our question. O and A are the sides that are involved, so it's going to be TOA. Whenever you want the angle, you cover up the S, the C or the T, depending on whether you're using SOH, CAT or TOA. We're covering up the T, and what's left behind is O divided by A. We know when we want an angle, we do tan to the minus 1. If we were doing SOH, we'd do sine to the minus 1, or CAT, we'd do cos to the minus 1. Always when you want an angle, it's going to be to the minus 1, and in the fraction is O divided by A. So the opposite 4 divided by the adjacent 1. To get tan to the minus 1, it's shift tan. I'm trying to get it on the screen for you there. And then in the bracket goes opposite on the top and adjacent on the bottom. You could just write 4, it doesn't really matter, but there we go. So it's 75.96375, blah, blah, blah. And it's, we're just going to leave it. So let's just round it to 75.96 degrees. They've put 76.0, but anything from 75.9 to 76 would be allowed. Okay, then the bottom bit says some different safety instructions say that the angle between the ladder and the ground should be 75 degrees. How does this affect the height? Well, we've said this 75.96. So 75 degrees would be bringing that angle smaller. How is that going to affect the height? Well, the height would go down. If we're decreasing the angle, h would decrease. Okay, Alex has got an interesting project about ducks going on. He wants to find out how many ducks there are in a park. One day he puts a tag on each of 30 of the ducks. The next day he catches 40 ducks. 8 of them have tags on. Work out an estimate for the number of ducks in the park. So if he's caught 40 ducks and 8 of them have tags on, we can use that to work out what proportion of the ducks he tagged. So 8 out of 40 is a fifth, or you can times it by 100 and work out that that is a fifth, so 20%. So on that day, he caught 20% of the ducks had tags on. So 8 out of 40, 20% of them had tags. And so what we're going to do is assume that the 30 he caught before were about 20% of the ducks population. So if 30 is 20%, then we would say 100% of the ducks would be 150, 5 times bigger. Alex assumed that none of the tags fell off during the night. If Alex's assumption is wrong, explain how this could affect your answer. So if tags have fallen off, Alex will have overestimated the number of ducks. So he will have overestimated how many ducks there are. Okay, quite difficult this question, but hopefully all of you have been able to get a mark for getting the area of this sector. Sector is like a pizza slice chunk of the circle. And so we're going to do pi times the radius squared. That would be the area of the whole circle. But then we're going to times it by the fraction of the circle that we want. And that's going to get us the area of this bit here. So pi times 30 squared times by 80 degrees out of 360 degrees. So pi times 30 squared times by 80 out of 360. And that's 200 pi. I could write it as 628.3185, but for now I'm just going to leave it as 200 pi, just because I probably am going to need to go on with that calculation and do more with it at some point. We then need to work out the area of the shaded bit. Now, to get the area of the shaded bit, I'm going to do the area of the triangle and take it away from this. The area of a triangle that is not base times height divided by 2, I can't do that with this, I don't have a base and a height. We do half AB sine C. So half AB sine C. A and B are your two sides, and sine C is your angle here. So half AB sine C. Typing that in my calculator. We get 443.163, blah, blah, blah. So let's do that. 443.1634889. Notice I did all of the digits, or as many as were on my calculator. Just I want to keep this answer as accurate as possible. And by doing that, I'm going to do that. However, what I want is the shaded bit up here. So to get that, I'm going to do 200 pi. And I'm going to take away the answer we just got. Again, using that answer button keeps everything really accurate. And that is 443.16, blah, 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 is 185.1550419. And that's the area of just this little top slither, the bit there, the shaded bit that they've asked us for. Now I want that as a percentage of the area of the whole circle. Work out what percentage of the area of the whole circle is shaded. So we've got that, which is the area of the slither, and I want that out of the area of the whole circle. So I want that answer, I'm going to put that on the top of a fraction, out of, now the area of the whole circle is pi times 30 squared. So I've done the slither. You see that on the calculator? Kind of. That way. There we go. I've done the area, the answer that I just got, out of pi times 30 squared. And I want that as a percentage, so I'm going to times it by 100. And that gives me 6.548. So 185.155 out of pi times 30 squared, which is 900 pi. So that's out of 900 pi times by 100 because we want it as a percentage. And your final answer is 6.54852, blah, blah, blah. So they asked me, oh, they didn't actually. So we'll just go 6.55. And again, you'd be allowed anything from 6.5 to 6.6. Here we have a speed time graph showing the speed in meters per second of an object t seconds after it started to move. We've got the speed on the y-axis and we've got the time on the x-axis. Use 3 strips of equal width to find an estimate for the area under the graph between T1 and T4. So I want to start finding the area when T is 1 all the way up to when t is 4. And I'm using 3 equal strips. So we're going to make each of these sections an equal strip. Now this topic is called the trapezium rule, and there is a formula, but all I will say is if that formula seems confusing, and I'll go through it in a minute, you need to consider the fact that this is 3 trapeziums, and all you really need to do is get the area of each. So if you find that easier, you can do that. Okay, so we're doing the area of this one, the area of this one, and the area of this one. Now, all of these trapeziums are actually turned on their side. If you imagine, normally the area of a trapezium is A add B divided by 2 times by the height. So your parallel sides are A and B. So if you imagine that formula, normally you do A add B divided by 2 times by the height. If you imagine that on its side, then it's probably easier to think of these as 3 trapeziums, and then you can work out the area of each and add it together. However, there is a trapezium rule, which is a little bit easier. So to do the trapezium rule, we need to take the height and divide it by 2. Now the height for each of these strips is 1. So we're going to do 1 divided by 2, and we times that by the first height, which is 3.6, add the last height, which is 9.6, add 2 lots of the heights that are in between, which in this case is 6.4 and 8.4. Okay, typing that into a calculator will give you the answer straight away. So that's slightly quicker than working out each trapezium. So it's the height, this height, sideways, divided by 2, times by the first, oh, I say it's height, but it's on its side. So the first one, add the last one, and then 2 lots of everything in between. So typing that in your calculator should give you 21.4. But equally, working out the area of that, the area of that, and the area of that using this trapezium rule would get you the same thing. Now we're told to describe fully what our answer to part A represents. Now, the way I make most sense of this is that we had a speed time graph and we found the area. Now, area is normally base times height. So if you think about time multiplied by speed, have a think about your speed, distance, time triangle. If you're doing speed multiplied by time, what you're finding is the distance. So it makes sense that doing a time multiplied by a speed, the area is going to be the distance. Now, distance gets you 1 mark, but you need to say in meters, because we know it's in meters from the meters per second and the fact that this is in seconds. So our answer is the distance in meters. Explain whether your answer is an underestimate or an overestimate. Well, if you think about the shape of a trapezium, each trapezium is slightly underneath the area of the graph because we're just taking a straight line there rather than following that curve. So it's an underestimate, as the chords, we call them chords, just like in a circle, the chord, as chords are under the curve. Okay, really difficult question here. P has coordinates -9, 7, and Q has coordinates 11, 12. So I'm actually going to give this a little sketch just to make it easier to explain it. So P is -9, 7, and Q, that would be a lot higher and to the right, is 11, 12. M is the point on the line segment PQ, such that P to M, M to Q, is 2 parts to 3 parts. So I'm going to say that M's about here. With the line that connects them, this is, I imagine it's a straight line, this is 2 parts and this is 3 parts, okay? And we need to get M. The line L is perpendicular to the line segment PQ, so it's going to be at right angles to this line, and it goes through M, so we've got a right angle here. Find the equation of this line. This is the line L, this one here, okay? So first thing we need to do is work out M. We need to find out M. Okay, now to get M, we know that it's 2/5 of the way from P to Q. So if to go across, we've gone from -9 to 11. We've gone 20 in the x direction. And to go from 7 up to 12, we've gone up by 5. So I want 2/5 of that. 2/5 of 20 divided by 5 times by 2 is 8. So we need to go 8 across in this direction, which should be -1. And 2/5 of going up 5 is 2. So we need to go up 2, which is going to be 9. So we now know that the point there is -1, 9. That's going to be helpful. I next need to work out the gradient of this line. If I can get the gradient of this line, then I can do the gradient of this line by doing the negative reciprocal. Okay? The gradient of a line is change in y divided by change in x. I'm looking at these two coordinates. Change in y is 12 take away 7, and change in x is 11 minus -9, which is 5 over 20, which is a quarter. So the gradient of this line is a quarter. The gradient of this line then is the negative reciprocal of that. So not only do we need to make it the reciprocal, which would be 4, we also know that if one line is going up and has a positive gradient, the other line is coming down and has a negative gradient, so -4. I can now tell you that the equation of the line is y equals -4x plus c. How are we going to work out the c? Well, we need a point that lies on the line. Luckily for us, we have that in M. So I'm going to use this point and what we know so far. I'm going to substitute in the x value and the y value of this point to get the equation of the line. So 9 equals, that's the y coordinate, -4 times -1, that's the x coordinate, add c. So 9 equals 4, add c, and so we now know that c must be 5. That means that the equation of the line is y equals -4x, add 5. We're going back to here, but we're just saying we now know what c is, so that's our final answer. Y equals -4x, add 5. And last but not least, OAB is a triangle. A is the midpoint of OZ, so A here is halfway. Y is the midpoint of AB, and X is a point on OB. We don't know how far along it is. It says that O to A is A, so I'm going to label that on here, and that's going in that direction. With vectors, it's really important to show your direction. O to X is 2B, so that's going that way, and that's 2B. And X to B is B. Prove that x, y, z is a straight line. Now, to show that two vectors, to show that a line is straight, we need to do the vector from x to y, and then do the vector from x to z. And if they are parallel, then we know that it must make a straight line because they're starting in the same point and they're going in exactly the same direction. To get from x to y, I'm going to go down here and then up here, but I first need to know what this is. So firstly, let's work out b to a. B to A we can only get by going round. So B to A is -3B, add A. When we go with the arrow, it's positive. When we go against the arrow, it's negative. So -3B, add A. And so B to Y would be half of that. And I'm going to work in decimals just because I find it easier with vectors, but you can work in fractions if you want. Add a half A. So -1.5B, add 0.5A. And that's going to get us from B to Y. It's just half of this. If -3B add A gets us from B to A, then halfway is that. If I then want to go from X to Y, I need to do this bit, X to B, and then I need to add on B to Y. X to B is B, and then B to Y is -1.5B, add 0.5A. Overall, we've got B, take away 1.5B, which is -0.5B, add 0.5A. For x to z, we know that this is halfway here, O to A, so I'm going to put another A here. For x to z, it's going to be -2B, add 2A. -2B, add 2A. And we can see now that this is 4 times bigger. So we are going to say that xz is a multiple of xy, so they are parallel. And since they start in the same place, we can then say, therefore, a straight line. And that's the proof done.